Happy day to all. Today we are going to see previous year NET exam questions in software engineering subject. Yes, let's begin. The first question, the main objective of designing various modules of a software system is, so when you are designing a module, when you are creating a function, okay, so modules of a software system, so what we have to remember, the main objective is cohesion and coupling, okay. So cohesion should be high, okay. What is cohesion? Cohesion is dependency within a function. Cohesion, okay, if I am specifying int a for a I am creating a get data function and this some variable a, okay. So this variable should be used within this module as much as possible. It should be within this module, okay. So a should be within this module, it should use, and coupling is outside, okay. Coupling means the interconnection between one and another, okay. Here something xyz function, okay. So this is coupling. So one function to another function, that is called coupling. So cohesion is the interdependency within this module. This should be high, okay, and this is an interaction between the another module. Coupling is an interaction between from one module to another module. So this should less, okay. So coupling should decrease. So decrease the coupling and increase the cohesion. The interdependency within the module, it should high, okay. The connection between from one module to another module, it should less, okay. For example, in a family, we have to take care of our family at first. The interdependency should be high, okay. The coupling, if you are interacting with other families, that should less as much as possible, okay. So in the same way, so here you have to design it, okay. The main objectives of designing various modules of a software system is to increase the cohesion, okay, to increase the cohesion and decrease the coupling, okay. So if you are increasing the coupling means what happens? Some confusion. If you are interacting with other family members or intervening with others, it will create problems, right? So in the same way, so coupling means you are passing the data from one module to another module and getting that means it will take some confusions, okay. So whatever data created for your function, that should be interdependency should be high, that this cohesion should be high. So increase the cohesion and decrease the coupling is the correct answer whenever you are creating and designing a module. So this is a repeated question, that's why I am explaining in detail. So remember again, the main objective of designing various modules of a software system is to increase the cohesion or high cohesion, okay. They will ask in a different words, increase the cohesion or high cohesion, okay, or cohesion should be high or something like that. Increase the cohesion and decrease the coupling. So option B is the correct answer. The next one, 3 essential components of a software project plan. So whenever you are creating a software, so what are the 3 essential things we have to remember? The components. First we are estimating the cost and we are estimating the time and the quality. So cost estimation, time estimation and quality assurance plan. This is the essential component. So in this option A is team structure. So team structure will be decided later, okay. So option B is the correct answer. Cost estimation, time estimation, quality assurance plan is the 3 essential component of a software project. The next question, reliability of a software is dependent on. Reliability means number of errors present in a software. Reliability means number of errors. So okay, whenever you have created a software, number of errors, which tells that reliability. If a particular software is coming off an error means it is low reliability. If there is no error, it is coming only once in a while, that is high reliability, okay. So reliability, the meaning of that reliability is directly proportion to number of errors present in a software. The next question. In transform analysis, input portion is called, in a transform analysis, input portion is called afferent branch. Okay. So normally we know that input, process, output, right? Okay. Normally we are giving input, process is CPU, and we are getting the output. So this process is called, in a transform analysis, it is called as afferent branch. In a input, that is called as an afferent branch, and the output is called as afferent branch. Afferent branch. And this process is called as central transform. The process is called as central transform. So they are asked what is the input portion name, that is afferent branch. Yes. The next question, the functional point metric, the functional point, whenever you calculate a number of functional points, number of processes we are going to use in a particular software. So it is used for calculating the software complexity. Okay, it is not for user requirements or line of code. It is used to calculate it from software complexity assessment. The next question, which of the following tool is not required during system analysis phase of a system development life cycle? So when your system analysis phase, okay, so in a software analysis life cycle model, analysis, designing, and coding and testing and implementation, right? So the first phase is analysis phase. Okay, so first phase is analysis phase. In this analysis phase, they are asking which tool is not required during the system analysis phase of system development life cycle. So case tool they used. Okay, in an analysis phase, the case tool used. RAD is rapid application development. So rapid application development. So whenever you want to complete a particular project within a 90 days, that time RAD tool is used. So reverse engineering tool. So this tool is used after creating the software. After creating a software, when you want to remodify a particular software, at that time only reverse engineering tool is used. So this won't used at the time of analysis phase. This will be used after creating, after delivered the project, after sometimes if you want to redesign a particular project or reverse a particular project, that time we are using to reverse engineering tool. So they are not, this tool is not used in analysis phase. So this is not, their question is not required during system analysis phase of system development life cycle. So option C is the correct answer. The next question, a black hole in a DFD is, so black hole in DFD is a data store with only inbound flows. So data storage, okay. So this is called as in a DFD data store. That is, this is considered this one as a student table, okay. Student table, you consist of all the student details, something like that. So which consists of only inbound flows. Inbound means number of arrows come inside this function. So that is inbound flows, a data store with only inbound flows, that is called as black hole. That is called as black hole, a data store. This is a data storage, okay, with only inbound flows. That is called as a black hole. Yes, the next question, the capability maturity model defines 5 levels. So CMM, this is also a repeated question. CMM, this capability maturity model is specially designed for a particular process. Okay, there are 5 levels. So level 1, level 2, level 3, level 4 and level 5. So the first level 1 indicates initial stage. The second level is repeatable. And the third level is defined, and fourth one is managed, and fifth one is optimized. So in this initial phase, what they are going to do is So in this initial phase, the software characteristic, how the software should be, what the software has to do. So that software characteristics are analyzed and fixed in this stage. Okay, and the next one is repeatable. Here cost and time and all will be analyzed. Suppose if a software is already created, the same software I can utilize it for a new software. So how much I can reduce the cost and time for this project. So that how can I repeat a particular software, repeat the already created software in new software. So that process is analyzed in level 2, and then level 3 defined. So here everything will be, all the software characteristic is documented. So if I am going to do 3 function for a mark list preparation, so I declared and I documented. So documentation process of all the software characteristic, all the software process, okay. So documentation, that is defined, and managed. Level 4 is managed. So managed, what we are doing is the software quality we are doing in a managed process. All the software process and how the software is working correctly or not. So that is handled in a managed process. That is nothing but a quality assurance will be handled. And optimized. Optimized means a continuous improvement of a particular product. Level 5 indicates optimized, continuous improvement of a particular project. Continuous improvement by getting the feedback. So by getting the feedback from the users, so we can improve it, right? Continuous improvement by getting the feedback. Okay. So feedback is in which phase? Optimized. Okay. So remember that. So level 1 is an initial, and level 2 is repeatable, and level 3 is defined, I'm defining the document, and level 4 is managed, and level 5 is optimized. So that option is available in option B. The next question, which one of the following is not a software process model? Linear sequential model, waterfall model, prototyping model. This is a questionnaire model, right? Questionnaire. So I am giving, if a particular person don't know about how to create a software, they are using a old version, right? So we are giving some questions to them and ask them to create it. So questionnaire. So that is called as a prototyping model. Okay, that is they used in a software process. And spiral model and COCOMO model. COCOMO model is for the constructive cost model. So this is used for cost estimation. This COCOMO model is used for cost estimation. They are not used this for software process model. So this is a cost estimation model. The question is, which of the following is not a software process model? So COCOMO model is the answer. Other 3 models we are used for the software create and process model. The next one, system development life cycle as following stages. So first one is analysis, right? First one is analysis, second one is designing, and then you are doing a coding and then testing. So 1, 3, 2, 4. So that option is not there. So not present in A, not present in B, not present in C. So D is an option D. None of the above is the answer. The next question, which one is a measure of software complexity? So to measure the software complexity, number of functional points are mostly used, and in different websites they are given different answers. In some website they are given number of line codes, number of man. So so up to this I can take number of functional points, or you can say all of the above. The next question is, which type of coupling is least preferred? So the type of coupling and type of cohesion is an important question. They are asked compulsorily one question in this. So coupling you can write, okay, content coupling, common coupling, control coupling, before that external, okay, external coupling, and stamp coupling, and data coupling. So data structure is passed from one module to another module. So coupling is passing one message from one module to another module, right? So there are the types of coupling is there. Types is content coupling, common coupling, and external coupling, control coupling, stamp coupling, and data coupling. So in this, which is least preferred? Least means the first one is least. Okay. Highly preferred is we have to pass the data from one module to another module. We should not pass the content to one module to another module. It will create a confusion. So we have to use it as much as least. And data coupling, we can use it. So this is highly recommended. This is a least preferred. So content coupling is the least preferred one, and data coupling is the highly preferred one. So the types of coupling is content. You remember the first word 𝐶, 𝗏𝐶, okay, 𝐶, 𝐶, 𝐸, 𝐶, and 𝑠, 𝑑. Okay, content coupling, common coupling, external coupling, control coupling, stamp coupling, and data coupling. So which is the least preferred? Content coupling. The next question, the testing of a software against SRS. So against SRS, software requirement specification, they are giving in a software requirement, right? So in this specification, whether it is accepting or not, we are seeing using the acceptance testing is the answer. The next one, the lower degree of cohesion, the lower degree. So the types of cohesion is there. So in the same way, whatever we have seen a coupling, types of coupling, in the same way cohesion is there. So types of cohesion is, remember F, S, C, 𝗙HC, PT, LC. Okay, remember the first word and then you will create it. This is function cohesion and sequential cohesion, communication cohesion, communication, procedural, and temporal, logical, and the next one is coincidental cohesion. So these are all the types of cohesion. The function cohesion should be, I already told in the first question, function cohesion should be high. So this is the highly recommended. Okay, this should be low. Coincidental, unnecessarily interfering with other functions, unnecessarily arguing. So this is called as an coincidental. Okay, so this should be low and this should be high. So they are asking, the question is the lower degree of cohesion. So the lower degree of cohesion is coincidental cohesion. Is the answer. Types of cohesion, remember this first letter F, S, C, P, T, L, C. F, S, C, P, T, L, C. Functional cohesion, sequential cohesion, communicational cohesion, procedural cohesion, temporal cohesion, logical and coincidental cohesion. The next question, the reliability of a software is directly dependent upon, the same question asked in a previous many of the years. Okay, the reliability of a software is directly represent the number of errors. The based on number of errors, it tells the reliability of the software. The next question, successive layer of design in software using bottom up. Okay, when you are going, this is when you are defining, newly defining, which is called as newly defining, top to bottom. This is called refinement or construction, because you are creating newly, right? So that is called construction or refinement. Okay, when you are going bottom to top, this is called as an abstraction. Okay, so the answer will be layer of abstraction. Bottom up design is called as layer of abstraction. The next question, sliding window concept of software project management is. So sliding window is in a network. So sliding window means a period of time. So it will be splitted into separate stages. So preparation of the various stages of development. So that is a concept of sliding window in project management. Preparation of various stages of development. The next question, in a software project planning, Work breakdown structure. Work breakdown structure is nothing but you are splitting the work to the many people. For example, if your department, all the department is not handled by a single person, right? So first of all, they are splitting BBA, BCom, BCA, BSc, they are splitting, okay? So after the splitting into the department, then they are doing the classes. So again splitting, class 1, class 2nd year, 3rd year, like that, right? So this work breakdown structure, this is called as work breakdown structure, WBS. This work breakdown structure is always in the tree format, it is not in the graph or Euler graph. This work breakdown structure is always in a tree format. The next one, in a software matrix, 𝐴𝐵 cyclomatic number is given by the following. So cyclomatic complexity formula is edges minus n plus 2p, right? Edges minus nodes plus 2p. E is an edges here. E is called as an edges. N is nodes. And p is connected components. Connected components. So E minus n plus 2p, which is available in option A. The next question, in a good software design, coupling is desirable. Dash coupling is here, it is a dash is missing. Dash coupling is desirable between model. So when you are designing a software, so coupling should be low, right? Lowest coupling is desirable, highest cohesion, okay? The next, system study yield the following. System study, why we are doing a system study? We have to analyze the requirement specification. Yes. So what are the requirements is actually needed from the client side? We have to analyze it. So we are taking that. And prevailing process description, we are doing a process. Yes. Data source identification. Yes. So option D is the correct answer, all the above. The next question, the COCOMO model is used for. So COCOMO is specially created for software cost estimation. What is the cost happen for the particular software project? Cost estimation is the exact answer. This is not a designing or cost approximation or not like that. So software cost estimation. COCOMO model is used for software cost estimation. The next question, which possibility among the following is invalid in case of a data flow diagram? So in a data flow diagram, what data is passed from one process. In a data flow, normally in a data flow diagram is used for how the data is flowed to the data storage. Okay. For example, you are accepting a particular application through website. The data are coming, okay, student number, name that you are recording, that will be stored in a student database record. So that is a data flow diagram. They are used only the data store concept, where the data is going from one store to another store. Whereas in a flow diagram, they have mentioned all the control structures. Okay. So the question is here, which possibility among the following is invalid? Invalid in case of data flow diagram. A process having inbound data flow more than outbound data flow. So a process is having inbound data flows more than this is a 1 output, 3 input. Is there any invalid? No. It is correct. So there may be 3 input and 1 output, right? They are asking which is invalid. A data flow between 2 processes. So one data can be passed to 2 processes. Okay, this is process A, this is process B. Same number is given, register number is given to the record set for table for hostel and also for the admission. Right. So the same number, a data flow between the process can be done. It is valid, right? The next one, a data flow between 2 data stores. Okay, one data cannot be in 2 data stores. For example, if student number is there only in this student table, It is not available in another table, right? Serial number is specific for this student table. So a data flow between two data stores is not possible. It is an invalid. Okay. So the answer is option C. And I will check out D also. A data store having more than one inbound data flows. So if there are more than one inbound is also, it's okay, correct. So option C is the correct answer. The next question, software cost performed index CPI is given by BCWP, budget cost of work performed. Software cost performance index. Okay. So ACWP means actual cost of work performed. BCWP means budget cost of work performed. So I am analyzing actual cost. Okay. Actual cost of work performed should be higher than should be less than BCWP. Budgeted cost of work performed. So BCWP by ACWP. For example, so actual cost is 10 rupees, but I am budgeted 15 rupees. Okay, then it is correct. That is which should be 1.5, right? It should be greater than 1. For a CPI, if CPI is greater than 1, if CPI, that is software cost performance index, the calculated value should be greater than 1. If it is lesser than 1 means what happened? If it is, I am spending 10 rupees, but I given the budget 5 rupees. Then what happened? This is a lesser than 1. So it should not accept, invalid. Okay. If CPI is greater than 1, it is valid. Okay. So remember, software cost performance index, that is BCWP divided by ACWP, that is budgeted cost of work performed divided by actual cost work performed. In this, if you calculated this CPI, cost performance index of a software, it should be always greater than 1. If it is always greater than 1, then it is valid. If it is lesser than 1, it is invalid. That's it. The next question is, software risk estimation involves following two tasks. That is, whenever you are doing a risk estimation, we are analyzing the two things. One is risk probability and risk impact as the answer. Risk probability, how many times this risk is happening and what is the impact of that particular risk. Okay.